So in Chapter 10, we are going to consider these things called parametric equations and then also polar coordinates. So a parametric equation is an equation where the x and y coordinates are each individually given by a third parameter. You can think of it as time, and as time varies over all real numbers, the ordered pair x comma y traces out a curve in three-dimensional space. So as it turns out, you can make some really sophisticated, very complex curves with parametric equations that are not functions. They can't be described by y equals f of x. And when I first saw parametric equations, it reminded me of something I played with when I was a kid, which is called a spirograph. And maybe you guys have seen Spirograph before. Maybe you had one when you were a kid. Maybe you played with one at your grandparents' house. But just relax for a minute, enjoy, and watch this spirograph creation. And there's the finished product. And I'm going to give you guys a chance to put your creative skills to work and do Spirograph yourself. At the end of this week's module, you'll find a link to the Spirograph contest and the Spirograph tool. The contest will close at the end of Chapter 10, so that's going to be Exam 4. And you can earn some extra credit. We're going to vote as a class on your creations. So something to look forward to. So let's take a look back at our example here. X is 2t and y is t squared minus 2. Let's try and discover what kind of curve this describes in parametric equations. So this ordered pair x of t, y of t, which is 2t comma t squared minus 2, and t is ranging from minus infinity to infinity, that traces out some kind of curve. And we want to get an idea, what does that curve look like? Well, when you first started graphing, the way that you did it was you picked x values and you plugged them into your equation. So we're going to pick t values here, some negative values, 0, and some positive values, and plug them into each of our equations, and we'll get ordered pairs. So 2 times negative 2, that is negative 4. 2 times negative 1, negative 2. 2 times 0, 2. 2 times 1. I'm sorry, 2 times 0 is 0, 2 times 1, 2, and 2 times 2, 4. Plug them in here. So negative 2 quantity squared is 4, minus 2 is 2. Negative 1 squared is 1, minus 2 is negative 1. 0 in here squared is 0, minus 2 is negative 2. 1 goes in there. Squared minus 2 is negative 1. And then 2 comes in, 2 squared minus 2 is positive 2. So here's our points, negative 4 comma 2, so 4 to the left, 2 up right there. That is at t equals negative 2. Negative 2, negative 1, so 2 to the left and 1 down right there. That's at t equal negative 1. T equals 0, we're at 0, negative 2, which is right here. T equals 1, we're at 2, negative 1, right there. That is a 0. And at t equals 2, we're at 4 comma 2, 4 to the right, 2 up right there. And if you connect the dots here, you get a parabola. So these parametric equations right here, that's just a parabola in disguise. Now we do have to direct this curve here. So the arrow points in the direction of increasing time. And I also want to make a note here that different parametric equations may give the same curve in xy space, but they give different parametric curves. In other words, order matters, and then also speed or direction on the curve matters. So if I traverse this curve twice as fast in time, that's a different parametric curve, even though it's the same geometric curve. So, and we'll look at some examples of that here in a little bit. Why don't you try Web of Science section 10.1, problem 1. So do some plotting there and try and plot a parametric curve for me.